Hi, I've been working quite a lot on VESC Tool recently and made a lot of progress. So right now there are about 130 files of source code and UI files, and most of the functionality from VESC Tool is implemented. So let's run a short demo. When you fire it up, it looks like this. There is a welcome page and a setup wizard button, which doesn't do anything right now because I'm working on the wizard, but this is in the current UI that I'm going to show the only thing that isn't implemented yet. But there is still a lot of testing that I need to do. So I have a VESC 6 here, hooked up to some analog throttles and a motor with an encoder, a PPM receiver, and it also has an antenna connected to this UFL connector for the NRF chip on the backside up here. It can be used with the NRF nunchuck. So let's connect. And the first thing VESC Tool does now is load the app and motor configuration from the VESC on connecting. And I think it has the default configuration now. We can read it just in case. Motor and app and write them back. And then we can set up this motor, and I'm going to show how to set up the ADC app as well. So go to Motor General, choose motor type FOC. You can see that I also have a question mark next to all parameters, and I tried to write some documentation about most parameters, or I think almost all parameters, while adding them to VESC Tool. I also made an editor for that. For example, the motor configuration can be edited in this editor, which I'm going to show a bit of later, and stored to an XML file. And when VESC Tool starts, it will load this XML file and present all the parameters. So FOC, decrease the current a bit, so that I don't hurt my hand on this motor. Write configuration. And since we're running FOC, we're going to the FOC page. And now it's organized such that in the general tab of the FOC page, you have all the parameters that you really have to set in order to get things running. And then you can go to the other tabs to do adjustments or set up the encoder and so on. But we start with this one. And for getting all of those parameters, we have this detection bar or panel here. And it also has a help button that describes what is going to detect and what you have to set to make the motor spin up, and what you can do if the motor doesn't spin up, how to tweak the parameters. So it's a lot easier to find out what things are doing in VESC Tool right now compared to VESC Tool, where I had to look at the forums and maybe watch some video on, or try to figure things out yourself. So first measure resistance and inductance, and then we measure flux linkage. It has to spin up the motor, so it will warn you about that first, and then you have to click OK. Let's see if it spins up. It does. Then we apply the inductance, resistance and flux linkage, current controller parameters, and observe again. Write the configuration, and we give it a try. Switch on keyboard control in real-time data. You can go to real-time data tab, and then I can use the arrow keys to run the motor as before. I also have added FOC tab to real-time data, where you can see the D and Q axis current when running the motor, which can be convenient for tuning the controller a bit. So now that the motor is working, we can go to the app configuration and set the app to ADC and write. I have made such that you don't have to reboot after changing app, so you should be able to change anything on the VESC now without needing a reboot, which is convenient. You can still do a reboot from the commands menu, but you shouldn't really need it. And then we go to the ADC app, make sure that control type is off. And also for the control type I wrote some help text so that you can see what all the different control types are doing. And the reason to have it off is that we're going to do some mapping. So in the mapping tab we can switch on real-time app data, and then we can see the output from both throttles. And now both of them are gray because we have set the mode to off. And if you set it to different modes, you can see, for example, in current, this one is not gray and it starts from 0. If you set it to current reverse center, then it will be minus 100 if it's at 0, and if you center it, it will be, well, 0%. So if you have a throttle that has a center somewhere, then you can use it in both directions in this mode. And you can try all the modes and see what the output is doing here. So what we want to do is map the voltages of the range of the throttles to, well, minimum maximum voltages in the configuration. You can also read a bit about that here. So first we reset the counters. Now you can see that it sets the minimum and maximum for both. So we move this hot sensor throttle to max, and then this one. They happen to have almost the same limits for some reason, and then we apply those voltages and write the configuration. You can see that they changed here, and now we should have well, about the full range when moving this one from the start to the beginning, and the same for this one. And we also have this invert function for the throttle. So if you set them to inverted and right, then both of them get inverted. And we might want to have an invert function for the other throttle as well. And I'm going to show how to implement that both in the firmware and also how to implement it in VESC Tool with the new configuration editor and so on, which isn't too bad, even including writing documentation and so on. So let's go to the source code of the VESC, and then we open the ADC app, and in the output function, or in the ADC thread, you can see that there is this config.voltage invert option, and you have it in two places, here and here, as you can see in Eclipse. And the first one is for power, so for throttle 1, and the other one is for brake, so for throttle 2, and it goes to the same bool. So what we want to do is press F3, which opens the struct where it's defined, and add another bool for voltage 2. Let's call it 2, go back, call it 2 here as well. And then, after adding it to the struct in data types and to the ADC app, we go to conf general and make sure that it's initialized when the VESC is booted the first time and reads the default configuration. So take this line, copy, paste, rename, and rename this default define as well. Now we get an error because we don't have it, so press F3 here and take this one, the if def, copy, paste, call it voltage 2, and it should work at this point. Now the next step is to define how to send the app configuration with the new parameter to VESC Tool and back. And for doing that, we go to commands, go to where it's the app configuration is serialized, which is let's see, about here. Look for the inverted button or inverted function, which is here. Copy this one, paste, set it to number 2, and do the same thing for the reading part. Save. And now the app configuration reading and writing will not be aligned with the old version of VESC and or BLDC tool after this point, because we have another parameter. And this is when I usually change well, firmware version, and also remove the compatibility with this version. So we go to comp general, change from 3.2 to 3.3, save, build, and that's it on the firmware part. Now we're going to update VESC Tool. So first we close it, go to, let's see, VESC interface, which is among the main sources and headers. Oh, wrong. And set the only compatible version to 3.3. Save and start. We can also go to Eclipse and upload the firmware. I have the SVD connector connected, so it should just work if I double click upload. Yeah, we'll probably finish. And now we go to Developer in VESC Tool and Parameter Editor AppConf, and scroll down to appADC.voltage inverted. Now you can see that you get an editor for this parameter with the name and the long name that's going to be presented in the lists. You can also see that in the preview. And the type, which is Boolean. If you choose a different type, for example double, then you get more parameters like the minimum, maximum. You can show it as a display, how many decimals, if it has any suffix, how to send it and receive it to and from the VESC, and so on. But this one is a Boolean, so it's really simple to set up. It only has default value that you can choose as an option. And for description, we're just going to rename it to ADC2 here. I can probably write a better description later. And the third tab is for setting the, well, define that is in the default app configuration. Now the reason to do that is that I have implemented a feature such that you can go to file and save configuration as C header, which is useful if you want to compile firmware that has a certain default configuration for some reason, that you don't have to hook it up to USB or Canvas and so and run the configuration. You can just compile the firmware and upload it and it will be configured. And you can also see in preview, you can see inverted DC1, so this is wrong. Inverted DC2 voltage, and also call it ADC2 voltage here. And when we save it and change the name, it is going to insert another parameter below the one that is selected right now. So click save, and you see that we have voltage 2 here. And also when we save, we update the editor. So you see invert voltage HC voltage 2, false. If you click help, we can see that it's for ADC2. And now we need to add it to the serialization order. And getting this right is important. So we want to have it at the same place as it is in commands, which is right after voltage inverted. So we go down to appADC.voltage inverted, which is here. Click on the plus, and it will well, automatically fill in this one that is selected here on the left, and click OK, and then you see it pops up after this one. We can also move it up or down, so if in case we get it wrong. And that's it for the parameter editor. Go to File, Save XML as, and in VESC Tool I have the resource folder, and I'm just going to overwrite the current app configuration. And close this one. And now we want to add it to the appADC mapping table. So go to VESC Tool, open the page for appADC. And you can see that this one is really simple, it's less than 50 lines of code. And we just take this line, copy and paste, call it voltage 2. And we should be done. So let's give it a try. Fire up VESC Tool, connect. We can see that we have firmware 3.3. You can also see it in the firmware tab that we're going to work on a bit more to have some default firmwares. And also store like the hardware version in the firmware. Yeah, and then we go to app ADC, go to mapping, and see that now we have both of them here. Go to app general, set it to ADC, write, switch on the real-time app data, and we have to do mapping again since we wrote the new firmware and so on. Should just move those, apply, write. Yeah, now the mapping is correct, and now we try to change inversion for voltage 1, true, right. Yes, not only this one is inverted. Invert the second one as well, right. Remove the first one. Yeah, so it seems to be working. So, yeah, that's my demo for today.